Hey math enthusiast, I'm here to go over the notes from section 4.7, which deals with isosceles and equilateral triangles. First, let's just start off with some basic definitions. So what is an isosceles triangle? So it's a triangle that has at least two congruent, I'm just going to use the symbol here, sides. So at least two congruent sides. All right, the two sides that are congruent are known as the legs. So those are the congruent sides, the two sides that have the same length. The third side that is not congruent is known as the base. So you could say that is the third side or the non-congruent side. If you want to write it shorthand and use the symbol, you can use the congruent symbol and kind of slash it out. That tells me it's not congruent. Next, we have the base angles. These are the angles that are adjacent to the base. All right, and as we said, the base is that non-congruent side. And the last term we have is the vertex angle. So this is the angle in the triangle that is formed by the legs. So where the two legs meet, that's where you'll find the vertex angle. So now we want to label all the parts in this isosceles triangle down below. First thing I notice is that these are the two sides that they marked as congruent. They each have one tick mark. So I know that the left side is a leg and the right side is a leg. That would make this third side down at the bottom the base. Now in this case, the base is at the bottom. That might not always be the case. Okay, maybe your isosceles triangle is going to look something like this, where it's on its side. In that case, the base would be off to the left. Okay, the other pieces I need to label are the angles. So we have angle 2 and angle 3, which are adjacent to my base, which means that those two angles are my base angles. I'll try to squeeze this in this little box, but both 2 and 3 are the same. They're both base angles, which leaves me with my last box up top. So this angle 1 up here, up at vertex A, okay, this angle is formed by the two legs, which means it is the vertex angle. Now, once again, you're not always going to find the vertex angle at the top of your isosceles triangle. In this triangle on the left, right here, we have the vertex angle. So just keep that in mind. Next, we have the two theorems in this section. So the first one is the base angles theorem. So if two sides of a triangle are congruent, so in this case, in triangle ABC, I'm referring to side AB and AC. If those two sides are congruent, then the angles opposite them are congruent. Then that goes on to say that angle C must be congruent to angle B. So in other words, if I'm given any isosceles triangle and I mark these two sides as being congruent, I can immediately mark my base angles as being congruent according to this base angles theorem. After that, we have the converse of the base angles theorem. So converse just means they flipped it around. So the first thing they mention is the two angles in the triangle that are congruent. So I'm going to start off with angle C and angle B that are congruent to one another. Then that tells me that the sides opposite them are congruent. So then that tells me that AB is going to be congruent to AC because the angles were congruent. So in other words, if I'm given some isosceles triangle and I know right away these base angles are congruent, then I can mark these two sides as being congruent because they initially told me that the base angles were congruent. After that, we just have a couple quick notes about equilateral triangles. So my definition, it's a triangle with three congruent sides, so all the sides have the same length. Now, if a triangle happens to be equilateral, where all the sides are the same length, then it must also be equiangular. So in other words, all the angles are going to have the same measurement. And if I flip that statement around and start with the fact that a triangle is equiangular, then that must mean that it is also equilateral or equilateral. Now, in addition to that, if it's going to be equiangular, all the angles are going to add up to 180. If I divide that by 3, that means each of my angles are always going to measure 60 degrees in an equilateral triangle. So let's take a look at this first example. So first thing I want to do is identify what type of triangle I'm looking at. So I can see that we have a tick mark here and a tick mark here. So right away I know that this is isosceles. So that means I can apply those two theorems that we talked about earlier. So in this case, if I have two sides that are congruent, I know that the angles opposite them are also congruent. Now, based on that, I can take these two expressions, this 6y minus 5, and set it equal to this 10y minus 41. Because I know that those base angles have to have the same measurement. So now when I go through and solve, I'm going to end up with 4y equals 36, and it looks like I end up with y equals 9. So one way to check my work is to take this y value and plug it back into my expressions. So we would have 6 times 9 minus 5. So I end up with 54 minus 5, which gives me 49 degrees. Now, if these base angles are congruent, I should get the same answer for my other angle. So we got 10 times 9 minus 41, which gives me 90 minus 41, which gives me 49. So yes, both my base angles are congruent. Both of them measure 49 degrees. Now, using that information, I can solve for my vertex angle up here. I know all my angles add up to 180 degrees. So what I'm going to do is I'm going to subtract the two angles that I do have, 49 and 49, which is going to leave me with 82 degrees. So now I know that 12x plus 22 equals 82. First thing I'm going to do is subtract that 22, which gives me with 12x equals 60, and x equals 5. Now, for the next example, let's focus on just one triangle at a time. So I'm just going to focus on this triangle on the left. And I'm actually going to redraw it a little bit larger down here, just so I can label everything. So I have 2 ticks here, I have 2 ticks here, I have 9x minus 26, and then up top here I have 11x plus 10. So once again, I know that I'm dealing with an isosceles triangle. I have two sides that are congruent. So that tells me that my base angles, this angle and this angle, so those are my base angles, those two are congruent. So since I already have an expression for this angle, I'm going to put that expression down here as well for this base angle. Okay, so now I have an expression for each one of my angles in this triangle. I know that all three of these angles are going to add up to 180 degrees. So let's add all three of them up. We have 11x, 11x, and 9x. So that gives me 31x. We have plus 10, and minus 26, which gives me negative 6. So I'm going to end up with 31x equals 186. And finally, it looks like I'm just going to end up with x equals 6. And once again, I can plug that in to check to see if I'm correct. So my two base angles are each going to be 76, and my vertex angle is going to be 28. And it looks like that checks out because all three of those do add up to 180. Now, to solve for y, let's focus on this triangle on the right now. So once again, I'm going to draw it a little bit larger down here just so we can fill in some things. We have one tick here, one tick here. Looks like this base angle, or sorry, the vertex angle is 5y plus 7. And then my base angle down here is 9y. Well, once again, according to that base angles theorem, these two base angles are going to be congruent. So I can fill in the expression 9y for that angle as well. Now, same idea as the previous problem. I know all three of these angles have to add up to 180 degrees. So we have 9y, 9y, and 7y, which gives me 25y, plus 5 equals 180. So I'm going to end up with 25y equals 175, and y equals 7. So the last thing I can do is take that value and plug it back in to find the measure of each of my angles. So it looks like we have 63 for my two base angles, 63 and 63, and then we end up with 54 for my vertex angle. Okay, let's take a look at this next example. And let's start off the same way that I've done with the previous examples. Let's just try to classify the triangles that I'm looking at. And I'm actually going to start with this triangle on the right. It looks like all three sides are marked as being congruent, which tells me right away that it's going to be equilateral, which also means that it's equiangular. So I do know that all of these angles inside here have the same measurement. So all of them are going to be 60. 60, 60, 60. Now, the next thing I notice is that we actually have a right angle up here. So that is this larger angle in blue. Well, I already identified the piece down here to be 60. So now I want to focus on the other piece up here. Well, together the two add up to 90. You have one that's 60, so that means the other half has to be 30. So I know that this green angle in here is 30 degrees. Okay. So I've cleaned everything up a little bit. I've gotten that 30 degrees and jotted it down. Now I want to focus on this triangle right here. So now we have an isosceles triangle. Two sides are congruent, and once again I can use that base angles theorem. So my two base angles, which would be this angle and this angle, are congruent. So right away I know both my base angles must measure 30. Now I can set up some equations to try to solve here. So I'm going to have 4x minus 2 equals 30, and 7y plus 9 equals 30. So now when I go through and solve, it looks like we end up with 4x equals 32, and x equals 8. On the right hand side, it looks like we end up with 7y equals 21 and y equals 3. So the next example from this section looks like this. And I want to start off the same way that I've done for each problem. I want to focus on just one triangle at a time. So I'm going to start with this triangle on the left. And the first thing I'm going to do is just redraw it, make it a little bit larger over here. So we have 2 ticks here, 2 ticks here. I have 51 up here. And then I have x here. Well, I can use that base angles theorem because I know I'm dealing with an isosceles triangle, which tells me that both of these base angles are going to have the same measurement, both of them are going to measure x, whatever x is. From there, I know all three of my angles are going to add up to 180. So we have 51 plus x plus x. We'll clean that up a little bit. I end up with 2x plus 51 equals 180. Then I'm going to end up with 2x equals 129. Now I can see right away I'm going to end up with a decimal here because it's an odd number. It looks like x is going to equal 64.5. So now I can go back to my picture and actually fill in what I do know. So we have 64.5 for x, which means that both of these angles are 64.5. Next, I want to focus on this triangle on the right. So I'm going to sketch that out a little bit larger. I'm going to stretch it a little bit just so we can fit what we need to inside. I know I have z here, I have y up here, and I have two sides that are congruent, making it another isosceles triangle, which tells me that my base angles are congruent. But there's a little bit more going on with this base angle down here. So if I were to extend it out like I did in my picture, what I'm going to find is this whole thing is actually a right angle. And I know, based on what I found earlier, that this angle on the left is 64.5. Well, since the two form a right angle, I can solve for that other angle. Now I know since my base angles are congruent, I can label this one as y as well. So for my equation, I can say that 64.5 plus y, the angle inside the triangle, together form this right angle. So together they're going to equal 90. Well, from there, it shouldn't be hard. I'm going to end up with a decimal. So y equals 25.5. So I've solved for y, 25.5. So if I go back to my original picture, I know this top angle is 25.5. The other base angle obviously has to be the same, 25.5. And then I have z. Well, I know if I were to add up all three of these angles, 25.5 plus 25.5 plus z, together they're going to equal 180. When I clean this up, I'm going to end up with z plus 51 equals 180. And it looks like z is going to equal 129. For the last example in this section, what I want to do is solve for x and then find the perimeter of the triangle. So I'm obviously focused on this triangle down below. First thing I want to do before I try to solve for anything is just classify the triangle. They haven't marked any of the sides, but they do show that these two angles are congruent. So in this case, if I use the converse for the base angles theorem, I know that the two sides opposite must be congruent. So I know right away I'm dealing with an isosceles triangle. Now I can take these two side lengths and set them equal to one another, because I just showed that the sides are congruent because of that converse base angles theorem. So it looks like I'm going to end up with 4x equals 18, which does not go in evenly, so I do end up with another decimal, x equals 4.5. Last thing I need to do is figure out what is my perimeter. So I'm going to take that x value and I'm going to plug it back in to each of these side lengths. So we got 4 times 4.5. I have 8 times 4.5 minus 15, which should be the same as the one above. These two should be the same. And then the last one I have is 5 times 4.5 plus 8. So it looks like my side lengths are going to be 21, because I'm going to have 18 plus 3. Then it looks like we're going to have 36 minus 15, which is going to give me 21 again. So those two are the same. And then for the last one, it looks like we're going to have 22.5 plus 8, which is going to give me 30.5. So the last thing I need to do to figure out my perimeter is add all three of these values up, 21, 21, 30.5, which gives me my final answer of 72.5 meters. And that is for my perimeter.